Now let's talk about what goes wrong. Because understanding failure modes is just as important as understanding best practices. There are three common prompt failures, and I would bet that most of us have experienced all three at some point. The first is ambiguous prompts. The example one on the slide is check that. That is the entire instruction. It is missing the feature, the platform, the expected behavior. Everything the model would need to produce something useful. The result is inconsistency. The model might generate something, but it will not be focused on what you are actually needed. The fix is simple. State the feature and the expected outcome explicitly. The second is unclear specified prompts. Generate login test is slightly better than check the app. At least there is a feature name, but it still leaves out the inputs, the steps, the validations, the negative cases, and the format. What you get back might be technically on topic, but too shallow to be useful. The fix is to include steps, data, and expected results in the original prompt. The third is overspecified prompts. This one surprises people. You might think being very detailed is always better. But if you say output exactly these 12 steps with verbatim text and then constrain every word, you end up with something brittle. Model cannot produce a smarter or more complete alternate because you have locked it too tightly. The fix is to define goals and format requirements, but leave room for model to make intelligent choices within those boundaries. Think of it as a dial. Too vague on one end, ambiguous or underspecified. Too rigid on the other side, overspecified. The goal is to be specific enough to get consistent, useful outputs, while remaining flexible enough that the model can produce the best version of what you need. Keep this dial in mind as we move into the hands-on exercises. All right, let's put this into practice. So this slide shows 5 real prompt transformations from weak to strong. And I want to walk through each one so you can see the pattern at work. First example, generate test cases becomes generate 10 negative login API test cases with steps, sample inputs, validations, including HTTP 401 and error code, and expected results. You can see every element of our checklist applied here. Count, scope, focus area, steps, data, validations, expected results. Second, write test cases for checkout becomes produce 8 checkout API cases with steps, payloads, assertions on totals and taxes, and expected 200 or 400 responses. Again, count is specified, the data type is named, payloads, and the assertions are described. Third, test email form becomes create invalid and boundary email cases with steps, inputs, UI messages, expected, and log checks. Notice that the format of what is expected is named UI messages and log checks so that the model knows where to look for validation. Fourth, test performance becomes plan 5 performance scenarios with load of 100 requests per second, a target response time under 300 milliseconds, an error rate below 1%, plus steps and expected matrices. This example shows that prompt engineering applies well beyond functional testing. Fifth, create test data becomes generate privacy-safe synthetic data with schema fields, examples, and validation rules. Output as a small table. This is great use case. Generating test data that is realistic but does not expose real user information. Now I want you to try this. Take a weak prompt from your own work, something you have actually used with an AI tool, and rewrite it using checklist, scope, count, steps, input data, validations, expected results, and outperformance. In the next section, we will take a look at the techniques that power the prompts writing. Okay.